Hi students, so welcome to the session. I am Dr. K.Varada Rajkumar, Associate Professor, Department of CSC, AIML, MLR Institute of Technology, Hyderabad. In today's class, we are going to learn about circular queue. So, overview of today's presentation. So, first we are going to know what is circular queue. Then we are going to discuss about the operations of circular queue. Outcome of this lecture, at the end of this lecture, you all are understand how circular queue is different from normal queue. In our previous two classes, we discussed about normal queue. Now, at the end of the class, you all are understand how the circular queue is different from normal queue. Okay. So, coming to definition, a circular queue is a data structure that functions as a queue where the last element is connected to the first element. So, this arrangement enables efficient space utilization compared to a simple linear queue. The difference between normal queue and circular queue is, in this the last element is connected to the first element. Okay. So, for example, consider, so this is the queue. So, let us assume the size is 5, 0, 1, 2, 3, 4. So, this is the name of the array queue. Okay. So, now I want to insert an element 10. So, this is the 10. Next 20, 30, 40, 50. So, how we insert? By using rare value, rare. Okay. So, this is the front. So, already we learned this in our previous classes. So, in this case, the front value equals to 0 and rare value equals to 4. Okay. So, this is the normal queue. So, now if I delete any number, so for example, I delete 10. Now, so this is the front value. So, this is the front value. Now, what is the front value? Front value is 1 now. Okay. So, now I want to insert another number 60, but if it is normal queue, it is not possible. Even though there is a space to insert an element, but we are not able to insert the element in that location in queue. But in circular queue, the last element is connected to the first element. So, this is the last element now. 50 is the last element. Now, so this will be connected to the first element. So, this is the circular queue. Now, how we organize this means, this is the organization. Okay. So, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 10, 20, 30, 40, 50. Now, if I delete 10, if there is a space, now I am going to insert the 60 in the 0th location. So, this is the circular queue. For better understanding, we are representing the array in a circular way. Okay. So, this is about the definition of circular queue. Circular queue is a data structure that functions as a queue where the last element is connected to the first element. So, last element, here the last element is the 60 is the last element. Now, this is the connected to the first element. Okay. This is the circular operation. Okay. In circular arrangement allows for the efficient use of memory and supports both FIFO and LIFO access patterns. Okay. Here we are going to access based on our requirement. Either you can use FIFO principle or LIFO. So, first in first out or last in first out. Okay. Here, so use of memory means here the element is deleted. So, this space we are going to use one more time. So, that we call as a efficient use of memory. Circular queue maintain 2 pointers. So, already we know that. So, one is front pointer, this is one variable, another one is rear pointer. Okay, so front pointer is also known as DQ pointer. So rear pointer we called as NQ pointer. The front pointer indicates the first element in the queue, while the rear pointer indicates the position where the next element will be inserted. So, okay, let us assume, so this is the array 0, 1, 2, 3, 4, these are the numbers, let us assume these are the numbers. Now, so this is the rear, so this is the front. Okay, now, so if I want to insert any element, I am going to insert at rear end. If I want to delete any element, then I am going to use front pointer, that is a front end. Okay. In circular queue, data structures is particularly useful in scenarios where memory usage needs to optimized. You understand? So based on our previous lectures, in queue, so this is the problem we are facing. We are not able to use if there is an empty space, but if you organize in a circular queue manner, then you are going to optimizing the memory. Okay, and when you want to implement a circular buffer that continuously overwrites the oldest data once the buffer is full. Okay, so what it means? So for example, so this is the data inserted. Now if I want to insert, just replace this. Okay, so that is, it is circular buffer. It overwrites the oldest data once the buffer is full. Okay, so this is about definition. What is the definition of circular queue? It is also linear data structure. It functions as that the last element is connected with the first element in the queue. Circular queue operations. Here we have NQ and DQ. So what is NQ? NQ means you try to insert an element into queue. So DQ means you try to remove the element from the queue. To insert an element into the circular queue, you increment the rear pointer and place the element in the location indicated by the rear pointer. If the rear pointer reaches the end of the queue, it wraps around to the beginning. What it is? Now, so this is the queue. Let us assume size is 4, 0, 1, 2, 3. So this is the queue. Now I insert the data. Where I am going to insert? Even though it is a circular queue, so first we are going to follow the properties of normal queue. Circular queue is also a normal queue. So if I want to insert the 10, I am going to insert here. So now this is the rear. Next, rear plus plus. So in this case, so this is the rear. Now I want to insert 30. Now this is the rear. Next I want to insert 40. So now this is the rear and I insert 40. Now if I want to insert one more element 50, but the first element is not deleted. This is the front, not deleted. So in this case we print the queue is full. Okay, let us assume if the first element is deleted, then we are going to check that if rear plus 1, okay, rear plus 1 percentage, this is the modulo operator, percentage size. What is the size here? 4 equals to front. So this is the condition to find the queue is full or not. Now in this case, what is the front value? This is the front. So this is the front. Now, so front value equals to 1 now. So what is the rear value? 3. Rear value is 3. Now 3 plus 1, 4. So 4 percentage 4. This modulus operator returns remainder. 4 percentage 4 remainder is 0. 0 equals to what is the front value? 1. It is false. So there is an empty space. So now we are going to increment the rear value and here I am going to insert the new data. Okay. If the rear pointer reaches the end of the queue, it wraps around to the beginning. Now it wraps around to the beginning. Okay, this is the circular queue. And DQ, it is similar to the normal queue only. It removes an element from the circular queue, increment the front pointer, effectively dequeuing the element. If the front pointer reaches the end of the queue, it wraps around to the beginning. So, for example, 20 deleted, so 30 deleted, now so 40 deleted. Now, this is the front value. Now, also the front again, so comes to indicating the first element. So, the front also indicating to the first element. Okay, now in this case, this is the front value. So, this is about insertion and deletion, NQ and DQ operation. So, empty and full condition. So, empty condition is if front equals to -1, then we say that the queue is empty. And what is the condition for full? Full means there is no slot to insert an element. So, how we know that means? By using this condition rare plus 1 percentage size equals to front. Then we assume that queue is full. Okay. Let us consider this example. Let us assume the size is 4, 0, 1, 2, 3. So, this is the name of the queue. Okay. So, now I want to enter 10. Yes, there is a space in the queue. So, I insert 10 here, 20, 30 and 40. Now, what is the rare value? Rare value equals to 3. So, what is the front value? Front value equals to 0. So, this is the rare and this is the front. Okay. So, now the queue is full. How we know that? Rare plus 1. What is the rare plus 1? 3. 3 plus 1? 4. Percentage size. What is the size here? 4 equals to what is the front value? 0. So, 4 percentage 4? 0. 0 equals to 0. True. Now, we display the message queue is full. Now, consider another case. For example, here I delete one element. So, I increment the front value. Okay, now what is the front value? 1 now. So, what is the rare value? 3. If I insert one more element, for example, I insert 50 here. Now, this is the rare. Okay. So, what is the index? 0. Now, is queue is full? Yes. In this case also queue is full. How we know that? Rare plus 1. Here what is the rare? 0. 0 plus 1. 1. Percentage, what is the size? 4 equals to front value. Front value is 1. 1 percentage 4, 1. 1 equals to 1. True. So, in this case also we are going to print the queue is empty. If I delete one more element, now this is the front value. Now, front value is 2. Now, queue is full or not? It is not full. So, how we know that? Check the condition. Rare plus 1. What is the rare? 0. 0 plus 1? 1. Percentage size 4 equals to front is 2. Now, 1 percentage 4? 1 equals to 2. It is false. So, there is a space to insert an element into queue. So, in this place now we are going to insert the data. That's it. Okay. So, display function we are going to use to display all the elements in the queue from front. So, that means now I want to print the numbers in this queue means first I print 30, 40, 50, 60. Okay. This is the expected output of circular queue. So, coming to summary of today's lecture. So, first we learn about the definition of the queue. A circular queue is a data structure that functions as queue where the last element is connected to the first element, and this circular arrangement allows for efficient use of memory and supports both the FIFO and LIFO axis patterns. Okay. So, next class we are going to learn how to implement circular queue in C programming. If you have any doubts, so place your doubts in the comment section I will answer all your questions. Thank you.